Hello everybody and welcome back to Environmental Science. So here we do heat, right, in all forms. So what are we trying to get done? We're going to talk about these ideas of energy, heat, temperature, and light, some of the confusion, get everything straightened out right away for what we're talking about. We'll talk about climate and heat in the context of Earth's history a little bit, how we got to where we are now, what's different about now compared to the past, and what that means, where it comes from. We'll talk about the greenhouse effect and other really important things that affect Earth's heat and Earth's air temperatures. We'll look at the consequences of heat, and especially excessive heat, as in caused by human beings, on ecological diversity and health and well-being of things in the ocean. And then finally, we come back to home, human beings, and a little bit on Phoenix in particular about the effects of high heat on human beings. Awesome. Got 4 sections on this one. I swear it'll be less than an hour. Okay, awesome. Energy, heat, and temperature is going to be the first part of it. So, heat and temperature are not the same. We've talked about this a little bit, right? So, heat is going to be a measure of the average amount of kinetic energy of the particles in something, right? So, if we've got hot water here, right, it's getting heat energy. And here, what happens to the particles? They start to move faster as they gain that heat. Now, that could be measured, how fast the particles are moving. The measurement of their energy is going to be temperature, right? So heat is the energy that's getting transferred, and then temperature is what we're actually measuring. Got to keep those straight, right? These images are just kind of a review of that concept, right? So all matter is made of particles. The particles are always moving around, right? Like in our pot of water, all the molecules moving around, bouncing into each other, crashing into each other, delivering their energy. More heat means that those particles are moving even faster, crashing into things and giving more energy when they do it. Awesome. Light is a little bit different, right? So there can be some confusion in this area of light and heat, and I've even had people try to tell me that they were the exact same thing because they kind of get too smart. There's like, doesn't know anything, and then there's like people who know something, but one of the writers are right. So we're going to get away from that. Okay, so everything is emitting light constantly if it's got temperature, right? So that includes me, that includes the whole Earth, that includes you, it includes, you know, all the objects and the sun and everything, right? But most of the light which gets emitted by these things is not light that we can see. It's really low energy light. A lot of it is going to be in this thing called the infrared spectrum, as in even lower energy than red light, which we can't see, but which is significant. And we'll put that into place in a moment, right? So these concepts, right? Light, radiation, heat, energy, photons, wavelengths, all right? We got to keep these things straight. Light is a form of radiation. Radiation being essentially this transfer of energy that does not require a medium. And I know I've introduced a new term, but basically we can transfer energy from one thing to another without having to have stuff in the middle that the heat travels through. Like what? Like the sun, and you have empty space, and you have Earth, right? So the sun is emitting light, and it's emitting heat, and it's emitting radiation. Light being a form of radiation. Right? That light has a certain amount of energy that is associated with it. Some light is higher energy, some light is lower energy. We're not going to worry about photons at all. It's not going to be a thing. Nothing that talks about light as being a particle for us, right? Different kinds of light have different wavelengths. Wavelength determines the energy. So if we move to our example here, right? So this part is colder, right? And we're slowly heating up as we get to this part, right? And the reason why the iron glows red hot is because once you raise the temperature high enough, it starts to emit light of a high enough energy that we can see it with our eyes in the visible spectrum. Okay, we're going to go over this again. I know it's a lot. So our sun is a star. Inside of it, atoms fuse together and release energy, right? They release energy in the form of electromagnetic radiation, which is what light is, beam it all the way to Earth and transfer it to us, all right? Everything is emitting light all the time. It's just that most things are emitting, radiating light in wavelengths that we cannot see because they're too low energy, right? So light is electromagnetic radiation. Nothing scary about that word. Travels through empty space. We don't really need to worry about why, but basically there's no such thing as nothing, and the whole universe has a fabric that conducts things. Awesome. This right here, right? So don't worry about the technical terms, all right? On the y-axis here, we have like intensity. Here we have wavelength, right? Smaller wavelength means it's vibrating faster. Bigger wavelength means it's vibrating slower. So this is highest energy stuff here, lowest energy stuff over here. Here is the light that we can see in the middle, right? So blue, green, right? We've got Roy G. Biv going backwards here, right? So red is the lowest energy light that we can see. And this thing, infrared, that I've been talking about, is going to include, well, don't quote me on it. It's going to include a lot of what I'm circling here. Maybe about in here we get to radio waves and microwaves and other stuff. Awesome. Radio waves, right? Really, really big wavelengths. So these are going to be wavelengths so big that they are bigger than entire buildings. You cannot possibly pick these up with your eyes. This is what radios use to be able to transmit information to each other, right? Going to be extremely low energy. On the other end, just to kind of skip, right, gamma rays are going to be the highest energy form of light, right? We look at the wavelength, right? So wavelength goes down as energy goes up. We're vibrating faster, yeah. Gamma rays, which we may have heard of, kind of a sci-fi term, extremely high. Notice X-rays on here, something we would have heard of, related to the reason why getting too many X-rays can be harmful, because you're exposed to high energy radiation. With a lot of this stuff, ultimately, it is the dose that makes the poison, so being exposed to X-rays once isn't harmful, doing it every time is, just why they leave the room for that part, right? We have ultraviolet light, which we might have heard about, being something that we put on sunscreen for, that is emitted by the sun that can burn people, right? We've got our visible light, right? Infrared, going to be smaller, all the way on down. Awesome. I'm going to leave this here for now, but it could be helpful to mark this out and come back as a reference if things get confusing later. Awesome. So this, right, with the sun, again, is just the same as what we've seen here, but broken down with a little bit more to explain. So very, very high energy stuff here. Most of what the sun emits, most of the light that the sun emits is, well, I should say the most intense light is going to be in the visible spectrum where we can see it. Then everything from here on out is infrared, and we can't. Don't worry about anything more than that for right now, right? Sun puts out lots of light. The most intense stuff we can see, most of it is most intense in the visible spectrum. And this will come back when we talk about human beings, right? So we are a product of natural selection, at least, it's complicated, but as far as physiological stuff goes, right? Your eyes are shaped by the selection process, same as in any other animals. Human beings have good vision, actually really good vision by the standards of the animal world. Not the best, but pretty good, right? You've got these things in your eyes, cones and rods, which are these types of light-sensitive cells. Cones see colors, rods are for night vision. You got three kind of cones in there, which are able to see corresponding to red, green, and blue, and cover all of that. And by combining those together, your brain can process the information and make these composite colors in the end, right? As in, when you look at stuff, you don't see the red, blue, and green parts. You just see it all merged together into one color. And as a result of this, and our brain being incredible at processing information, we can see about 10 million different colors. Some people are definitely much better at distinguishing these than others. I remember hearing that the famous painter Salvador Dali could tell the difference between like 30 different distinct shades of gray and had his own ideas of what each one, meant, or like a word for each one, which is incredible, right? But regardless, physiologically, your eye could see 10 million. Other animals can see, and can see a lot of what we see, but it's going to be different, right? So ultimately what it comes down to is whatever is going to help that animal best adapt to its environment, right? So, well, dogs being colorblind, okay, you got me. I might put it in a note. I don't really know how that's adaptive, but it's true. So dogs see, well, instead of having three, right, instead of having a red, blue, and green, the way that human beings do, they have only two of those types of cones, so they're partially colorblind. Snakes, right? So we might have heard somewhere, or, I don't know, watched the movie Predator or something, right? Being able to sense body heat, right? Then they put the mud on themselves so that, okay, yeah. So human beings are constantly emitting light in the infrared spectrum, right? We can't see it because our eyes aren't meant to be able to see that, but snakes are able to sense this light, which is how they can track things based on temperature in their environment. Birds and bees can see ultraviolet. It allows them to pick up signals from flowers, I want to say in particular. I'll put it in a note as far as the exact adaptation. There is this thing called the mantis shrimp, which is a horribly cute, colorful animal if you want to Google it. Thought to be able to see far more colors than human beings and have something like 16 different color receptor types, as opposed to our 3 in their eyes. Awesome. So that is going to conclude everything as far as our intro on what is light, heat, temperature. Next, we talk about Earth's heat and why it's so hot.